Hello everyone, myself Sanskar Chavan from MIT Academy of Engineering. So the topic of today's presentation is bearing capacity of a shallow foundation. What is bearing capacity? Bearing capacity is the capacity of a soil to support the load applied by the ground. The bearing capacity of a soil is the maximum average contact pressure between the foundation and the soil. So why the foundation is required? Foundation is required to distribute the load of a superstructure to the large area of a soil. So there are some design criteria for the foundation. So the soil should be below the foundation, should not be fail in a shear, and there should be not be excessive settlement. These are some basic terminology of a bearing capacity of a soil. Ultimate bearing capacity. The ultimate bearing capacity is the gross pressure at the base of the foundation at which the soil fails in a shear. Then after, net ultimate bearing capacity. It is a net increase in a pressure at the base of the foundation that causes shear failure of the soil. Net self bearing capacity. It is a net soil pressure which can be safely applied to a soil considering only shear failure. This is what the formula of a net self bearing capacity. QNS is equal to QNU is upon factor of safety. Factor of safety is usually taken to 2 to 3%. 2 to 3. Then after gross safe bearing capacity, it is the maximum pressure can be of the soil can be carried by the soil safely. The formula of this gross safe bearing capacity is QS is equal to QNU upon factor of safety into gamma df. Then fifth one is the net safe settlement pressure. It is a net pressure which the soil can carry without exceeding allowable settlement. Then after sixth one is the net allowable bearing pressure. It is a net bearing pressure can be used for design of a foundation. It is also known as a allowable soil pressure. Thereafter, the basics is a scientist which introduced the mode of shear failures in 1973, and basics has classified the three shear failure modes. That is what the general shear failure, local shear failure, and punching shear failure. General shear failure. The load settlement curve in the case of a footing resting on a surface of a dense soil, dense sand, or a steep clay shows a pronounced peak or failure occur at a very small strain. A loaded base on such soil shrink or tilt suddenly in the ground, showing a surface hue of adjoining soil. The shearing strength is fully mobilized all along the slip surface, and a huge failure plane are well defined. The failure occur at a very small vertical strain accompanied accompanied strain. So there are then after there are some factors, that is ID should greater than 65, N should be greater than 35, and phi should be greater than 36, and E should be less than 0.55 are the condition of a general shear failure. So mainly general shear failure only occur in a dense sand or stiff clay. Local shear failure. When the load is equal to a certain value Qu1, then the foundation movement is accompanied by the sudden jerk. The failure surface gradually extend out towards from the foundation. Then after the failure start at a localized spot beneath the foundation and migrate outward part by part, gradually leading to ultimate failure. Then after the shear strength of a soil is not fully mobilized along a plane, and hence the failure plane are not defined clearly. The failure occurred at a vertical strain and a very small lateral strain. So ID is equal to 15 to 65, N is equal to 10 to 30, and phi should be less than 30, and E should be greater than 0.75. So this general shear failure is mainly occur in medium sand or a medium clay. So in this failure, the hue or a failure surface is not clearly defined, and the shear strength of the soil is not fully mobilized. So third one is the punching shear failure. In this failure, the load base sink into the soil like a punch, and the failure surface do not extend up to the ground surface. No hue is observed in this failure, and a large vertical strain are involved with partial no lateral deformation. Then after, the failure plane are difficult to locate 2 to 2. So mainly this general shear failure occur in marshy land. So then after, there is the bearing capacity theory of a Terzaghi. Parandals in 1920 proposed a theory of a bearing capacity based on considering a strip footing with a smooth base that swings vertically downward when it is placed on the ground surface. Then after, Terzaki's theory is proposed in 1943. It was based on Parandal's theory of a bearing analysis, a shallow continue footing by making some assumptions, while all the modern theories of a bearing capacity are based on the Terzaki's theory. So Terzaghi is also known as the for this that the Terzaghi is also known as the father of foundation engineering. So then after, the Terzaki's bearing capacity theory. This theory states that the foundation is shallow if the depth is less than or equal to the width. Then after, Terzaghi gave a general theory of determination of ultimate bearing capacity of a strip footing. A strip footing is a continuous footing provided to support the wall or the load bearing structure. Then after, the footing is assumed as a continuous if the length and width ratio is more than 10, so that the problem is assumed to be a two-dimensional. In the in Tarzaki's bearing capacity, Tarzaki has stated that the foundation has a failure in the three phases. That is what the first phase, second phase, and third phase. First phase is a overburden, and second phase is a radial, and third phase is a density. So on this basis of the three zones, Tarzaki has introduced this formula, which is standard. That is what the QU is equal to CNC plus QNQ plus 0.5 gamma B and gamma, where the Q is equal to gamma DF. Then several theories of a bearing capacity were developed later by taking into account the effect of the shape and the depth of a footing, inclination of a load of a ground, etc. But the same form of a Tarzaki's equation was usually used by the all the investigations and all the scientists were used. The basic term of a bearing capacity formula were used. Then these are the some factors Cn, Nc, Nq, N gamma factors on the basis of the phi. Thereafter, the Target bearing capacity for square, rectangular, and circular footing. So for the circular footing, the formula is that 1.3 CNC plus gamma dash sigma dash into NQ plus 0.3 gamma B and gamma. Then after, for the square footing is 1.3 CNC plus sigma dash NQ plus 0.4 gamma B and gamma. Then for the rectangular footing, the formula is CNC in bracket 1 plus 0.3 B upon L plus sigma dash NQ plus 0.4 gamma P and gamma. So after that, after some various theories has introduced, the IS code equation of a bearing capacity were introduced, and this was introduced in IS 6403 in 1971. It is adopted as then after it is adopted as a general form of equation. Oh, so that what is that general form of equation? Q N U is equal to C N C S C D C I C plus Q in bracket N Q minus 1 bracket close S Q D Q I Q plus 0.5 gamma B N R S R D R I R W, where the NC, NC, NQ, NR are the bearing capacity factor, SC, SQ, SR are the shape factors, DC, DQ, DR are the depth factors, IC, IQ, IR are the inclination factors. This is standard general form of equation after various theories were introduced. After that, this formula is came. Thank you.